Pleasant good morning to one and all. This is Maria Pushpam, and for today's class, we are going to see the problems based on Halflife Period and geiger nuttal rule. So, these are the two things we are going to see for today's class. So, first, we can see the problems based on Halflife Period. So the first problem is 1 gram of radium is reduced to 0.998 gram in 5 years. Calculate the half-life period of radium. I'll repeat. So the problem is 1 gram of radium is reduced to 0.998 gram in 5 years. So we have to calculate the half-life period of radium. And directly we can't calculate this. So what and all we have to do here is you have to find the value of lambda. So first find the value of lambda. Using lambda you can find the half-life period. Is it okay? So I'll go into the problem. So two formulas you have to by heart for this one. One is lambda is equal to 2.303 divided by t log to the base 10 n0 by n. Another one is t is equal to 0.693 divided by lambda. So first we can calculate lambda. Lambda is equal to 2.303 divided by the number of years. Time is nothing but 5 years. So 5 into log initial amount of substance present is 1 gram. So n0 is equal to 1 and n is equal to 0.998 grams. So we have to substitute the value. So get the answer as 41.45 into 10 to the power of minus 5 per year. So this is the answer you get for lambda. I'll repeat. So the formula is 2.303 divided by t into log to the base 10 n0 by n. So 2.303 divided by t is nothing but 5 and to log to the base 10 n is nothing but 0.998 n0 is 1. So you substitute the value, you get the answer as 41.45 into 10 to the power of minus 5 years. So coming to half-life period, what you can do here is substitute the value of lambda in t is equal to 0.693 divided by lambda. So if you substitute the value, that is t is nothing but half-life period. So t is equal to 0.693 divided by lambda, which is equal to 0.693 divided by 41.45 into 10 to the power of minus 5. You get the answer as 1672 years. That is nothing but 1672 years. I'll repeat. So the final thing is half-life period is t is equal to 0.693 divided by lambda. If you substitute the value of lambda is nothing but 41.45 10 to the power of minus 5. The answer is 1672 years. And coming to the second problem, a radioactive isotope has a half-life period of 20 years. If 1 gram of the isotope is taken, what will be the remaining after 40 days? So, a radioactive isotope half-life period is said to be 20 days. Okay. If 1 gram of the isotope is taken, what weight it will remain after 40 days? For 20 days a half-life period is given, 1 gram of substance is given. So what will be the thing remaining after 40 days? So the formula you can use here is there is nothing but A is equal to A0 into 1 by 2 T by T. I'll repeat. A is equal to A0 into 1 by 2 the whole power T divided by capital T. So A0 is nothing but initial amount present. It's nothing but 1 gram. So 1 into 1 by 2 the whole power T is number of after number of how many years? Current time is nothing but 40 days. After 40 days what happened, we have to go to calculate. So 40 divided by half-life period is given as capital T, which is 20. So if you substitute the values, you get the final answer as 1 by 2 the whole power 2, which is nothing but 1 by 4, and your answer is 0.25 gram. Is it clear? So 1 gram of substance is given. Its half-life period is 20 days. And the question is, after 40 days, what will be remaining? The final answer is nothing but 0.25 gram. It's very simple. So A is equal to A0 into 1 by 2 small t divided by capital T, and capital T is nothing but half-life period. A0 is the initial amount present, and we need to calculate what is the final amount remaining after 40 days. So 40 days is nothing but small t. You substitute the value, you get the answer as 0.25 gram. Is it okay? So coming to the third problem, a radioactive substance undergoes 50% decomposition in 50 days. I'll repeat, a radioactive substance undergoes 50% decomposition in 50 days. At what time it will undergo 75% decomposition? புரியுதமா என்ன சொல்கிறேன்னு? 50% ஆஃப் ஒரு சப்ஸ்டன்ஸ் டீகம்போஸ் ஆகிறதுக்கு 50 நாள் ஆகிருக்கு. ஸோ 75% டீகம்போஸ் ஆகிறதுக்கு எவ்வளோ நாள் ஆகும்னு கேட்டிருக்கு. ஸோ யூ ஹேவ் டு ரிமெம்பர் அ பாயிண்ட் வெரி கிளியர்லி. 50% டீகம்போஸ் ஆகிறதுக்கு எவ்வளோ டைம் ஆகிருக்கு? 50 days. ஸோ அந்த 50%ல் இன்னொரு 50% ஆகும்னா அதே 50 days தான் ஆகும். ஸோ 25% டீகம்போசிஷனுக்கு உனக்கு எவ்வளோ டேஸ் ஆகும்னா 50 days. ஸோ 50 plus 25% is nothing but 75%. So what you can finally say is time required for 75% decomposition is equal to 50 plus 50, which is nothing but 100 days. I'll repeat the same thing once again. So third problem, the question is 50% decomposition requires 50 days. At what time it will 75% decomposition will take place is the question. Is it okay? ஸோ நல்ல ஞாபகம் வச்சுக்கோ, எப்போவுமே ரேடியோ ஆக்டிவ் சப்ஸ்டன்ஸ் 100% டீகம்போசிஷன் நடக்காது. ஸோ 50% டீகம்போஷன் அதுக்கு எவ்வளோ டைம் ஆகும்னா 50 நாள் ஆகும்னு சொல்லியிருக்கான். சரியா? ஸோ அதில் 50% டீகம்போஷன் ஆகணும், அதே 50 நாள் ஆகும். ஸோ அதுலேயும் 50% அதே 50 days. Is it okay? So how you can calculate here is, so 50% decomposition takes 50 days. Again, if you take 25% decomposition of that particular thing, it will take again 50 days. Okay, so altogether for 75% decomposition, 50 plus 50 days, which is nothing but 100 days. Is it clear? So next one we can go with geiger-nuttal rule. So what I mean by this geiger-nuttal rule is, if you take alpha particle, they are capable of ionizing gas through which they pass, and after traveling a distance they ionize the ionization power will be lost, and the distance of which the alpha particle travel in a gas we call it as range. I'll repeat. So if you take alpha particle is capable of ionizing gas through which they pass. Okay, so after traveling the distance they lose their ionizing power, and this distance the alpha particle travels in a gas we call it as range. In general, which decay slowly, that is the alpha particles which decay slowly emits, which is having a very short range. Okay, if you take alpha particle, if it is decaying very slowly, so it will have a short range. Geiger-Nuttal proposed an empirical relationship. Two scientists, they proposed a relationship between range as well as decay constant, that is R and lambda. So it is given by the correlation. I'll say the equation. You have a correlation between range and decay constant is given as log lambda is equal to A plus B log R. I'll repeat, log lambda is equal to A plus B log R. So this was proposed, this empirical relationship was given by Geiger and Nuttal. Is it okay? Both the scientists have empirically related this range with decay constant lambda, and if you take this A and B in this equation, they are said to be constant. A and B are said to be constant. Okay, so this relation we call it as, that is log lambda is equal to A plus B log R. This relation we call it as Geiger-Nuttal rule. Okay, if log lambda is plotted against log R for different alpha particles, that is alpha emitting particles, in the 3 series, 3 parallel straight lines were obtained, one line for each series. So if you plot these two curves, it's nothing but log lambda on the log lambda as well as log R, we get 3 straight lines for each series. One series is getting one straight line. So this law is very helpful in determining the decay constant and hence the half-life period of the product of disintegration, which could not be found out by any other way. So this is very useful to check the validity of any theory for alpha decay. Is it clear with the point? So I'll show the graph for you. So this is a graph obtained by plotting log lambda and log r. Is it okay? So for uranium series you have a straight line, then for thorium series you are having, then actinium series we are having. So this geiger and nuttal rule is very important. It's very useful in determining the decay constant, and also by finding the decay constant we can find the half-life period of any product which undergoes disintegration. Is it okay? So there is no other way to find all these things. So it is used to check the validity of any theory of alpha decay. Is it okay? So I'll repeat this geiger-nuttal rule once again. So according to them, normally if you take alpha particle, they ionize the gas through which they pass. As ionization takes place, they travel a distance and lose their ionizing power. So the distance which the alpha particle travel, we call that as range. புரிஞ்சாமா என்ன சொல்கிறேன்னு? ஆல்ஃபா பார்ட்டிக்கல் என்ன பண்ணும், அது எந்த கேஸ் வழியாக பாஸ் ஆகி போதோ அது போகிற வழியெல்லாம் கேஸஸை வந்து அயனைஸ் பண்ணிகிட்டே போகும். ஒரு குறிப்பிட்ட டிஸ்டன்ஸ் போனதுக்கப்புறம் என்ன பண்ணுன்னா அந்த அயனைசிங் பவரை வந்து அது லூஸ் பண்ணிடும். Is it okay? And this distance traveled by the alpha particle to ionize the gas is called as range. Is it okay? So now we can correlate this range with the decay. That is, the decaying will take place, whichever alpha particle is having a short range, it will decay very slowly. Which is having a long range will decay very fastly. So Geiger and Nuttal, these two scientists have proposed a empirical relationship between range as well as decay constant lambda. Is it okay? And is given by the equation log lambda is equal to a plus b log r. சரியாப்பா? So that's a correlation given. So we have to plot log lambda versus log r, and from this we can find the decay constant. And if you are able to find the decay constant, we can find the half-life period for any disintegrating product, which could not be otherwise determined very easily. So it is also used to check the validity of any theory based on alpha decay. Is it okay? So Geiger and Nuttal correlated these equation, and they found that all the radioactive particles which fall under this category is it is producing a straight line. And if you take the three series, uranium series, thorium series as well as actinium series, all are giving a straight line by plotting graph between decay constant as well as range. Is it clear with the point? So I think you are able to understand the class what I have taken for today. We can have a short glance. So today we have seen half-life period problems. So the formulas what we have used there is, first one is lambda is equal to 2.303 divided by t into log to the base 10 n0 by n. Another one is half-life period t is equal to 0.693 divided by lambda. Lambda is nothing but decay constant. Again we have studied a formula, capital A is equal to A0 into half the whole power small t divided by capital T. And finally we have studied this Geiger-Nuttal rule, and which is a rule which is correlating range with decay constant, and this rule is very useful for determining the decay constant, and from the decay constant we can find the half-life period of any substance which undergoes disintegration. Is it clear with the point? I think you are able to understand the class. Thank you for listening. Continue studying, ma. Thank you.